This is Maya. Let's get into it. Your RAG system didn't hallucinate. It retrieved an outdated document with a 0.94 similarity score and answered with total confidence. Here's how it usually happens. You build an internal AI assistant or support agent. You wire up a vector database, embed your company documentation, and run evaluation tests. In staging, everything looks brilliant. The system retrieves documents instantly and gives precise, context-grounded answers. Then, 6 months pass in production. A customer asks your system, "How do we authenticate requests against our primary API endpoint?" The system returns a step-by-step answer. It is confident, well-structured, and completely wrong. It gives instructions for an OAuth 1.0 architecture that your engineering team deprecated 6 months ago. When your team inspects the query logs, the dashboard doesn't show a failure. The vector database logged a 0.94 cosine similarity score for the retrieved context chunk. The retrieval metric says the match was practically perfect. And that is the gap. Most enterprise teams assume a high similarity score equals an accurate answer. In reality, vector embeddings only measure semantic similarity, how words and concepts relate in high-dimensional vector space. Vector databases do not naturally understand time, document lifecycle states, or business logic updates. When your team updated the API documentation in your primary knowledge base, the legacy chunks remained indexed in your vector store. Because the semantic concepts of API authentication still matched the user's question perfectly, the database served up stale data with 94% confidence. The large language model didn't fail. Your vector index drifted. To solve this in production, you have to separate semantic search from metadata governance. A bad architecture relies on raw vector similarity search alone. A good architecture uses hybrid search with hard metadata time decay filtering. Every chunk in your vector store must carry structured metadata headers, specifically created at, updated at, document version, and deprecation status. At query execution time, your retrieval layer shouldn't just ask the vector store, "Find me similar text." It must pass an explicit filter that strips out deprecated or outdated records before nearest neighbor calculation even begins. And if a document is updated or deleted in your primary database, that change must trigger an automated deletion or re-embedding event in your vector index immediately. Not in a batch job next weekend, immediately. If your retrieval layer isn't checking document timestamps and lifecycle metadata at runtime, your AI agents are making executive decisions on last quarter's rules. High similarity scores don't mean right answers. They just mean similar words. If you are deploying AI agents and need real control towers over your retrieval workflows, share this with your lead AI engineer. See you next time!